Greetings and welcome to Dreamy Discoveries. We'll look beyond our own galaxy tonight and see a giant hiding in the shadows. Andromeda. It looks like a faint fuzz in the sky to the unaided eye. In actuality, however, it is a massive system with over 1 trillion stars. Glowing softly through the blackness of space, its arms sweep across hundreds of thousands of light years. Long before the first humans set foot on Earth, more than 2 million years ago, the light that we see started its journey. Every gleam we see tells the tale of a far-off sun, a dust cloud, or an unreachable world. Stars are emerging, colliding, and vanishing inside those enormous arms. Andromeda is not merely an additional source of light. Moving gradually toward us through the emptiness, it is our closest great buddy. It will combine with the Milky Way in billions of years to create something very different. You can like, subscribe, or leave a comment below if you like these serene excursions. One drowsy soul at a time, it aids others in making their way here as well. For now, though, you just need to unwind. Let your mind relax and your breathing slow, and allow the cosmos to take you to sleep. Now let's get started. The nearest big galaxy to Earth is Andromeda. Andromeda is the closest big spiral to the Milky Way among the innumerable galaxies dispersed over the cosmos. It is located a little more than 2 million light-years away, a tiny distance in relation to the universe, but enormous beyond comprehension. Because of this proximity, scientists have a unique opportunity to observe a galaxy that is comparable to our own from the outside. Learning about the formation and movement of stars, gas, and dust inside its arms, Andromeda's structure is visible with strong telescopes. With lanes of dust slicing through rivers of starlight that spiral toward its core, its luminous disk extends over the night. Each picture provides a peek of a well-known order shaped on a larger size. Andromeda serves as a mirror, reflecting the appearance of our home galaxy to distant observers. It is one of the most studied objects in contemporary astronomy due to its proximity, an actual illustration of how galaxies develop, interact, and change throughout time. We see a neighbor in its light, but we also see a glimpse of our own far-off future scrawled across the sky. An estimated 1 trillion suns are located inside Andromeda's massive spiral. Every one of them burns with a unique rhythm, color, and intensity. Every part of the galaxy is filled with these stars. From the sweeping spiral arms that curl outward into the silent darkness, to the dense core bulge filled with old suns, some are enormous, vivid blue giants that have brief, violent lives before collapsing into supernovae that release heavy materials into the surrounding universe. Others are small, red dwarfs that will continue to light for trillions of years, burning continuously but dimly. When combined, they produce a light that is strong enough to be seen through 2 million light-years of emptiness. Andromeda's immense star population is what gives it its majesty and gravitas. There would be an unimaginable number of worlds in that galaxy, possibly with more possible habitats for life than there are grains of sand on every beach, if even a small percentage of them were home to planets. It is visible to the unaided eye from a dark sky on Earth. Anyone who is patient enough to look can see the Andromeda galaxy on a clear, moonless night away from the glare of city lights. In the Andromeda constellation, it appears as a tiny, hazy oval that shines faintly against the blackness. It is the combined light of more than 1 trillion stars, not a trick of the eye. It was a mystery to ancient watchers, a spectral cloud that appeared to be neither a planet nor a star, existing silently on the brink of consciousness. Humanity didn't start to see its true nature until the invention of telescopes, when they realized that it wasn't just a cloud, but rather an entire galaxy. You are witnessing light that started its journey millions of years before written history when you discover it with your own eyes. You are connecting with the same radiance that innumerable generations before you have seen while staring across both space and time. It was formerly believed to be a cloud inside the Milky Way. Astronomers thought the Andromeda galaxy was a tiny nebula inside the Milky Way for centuries. Observers assumed it must be a cloud of gas or dust because early telescopes only saw a weak, hazy patch of light. Known as the Andromeda Nebula in the 17th and 18th centuries, it was one of several hazy objects that early astronomers catalogued. Until Edwin Hubble conducted a more thorough investigation of it in the 1920s using the 100-inch telescope at Mount Wilson Observatory, this idea remained. He discovered a unique type of star in the cloud called a Cepheid variable, whose distance is revealed by its rhythmic brightening and dimming. According to his estimations, Andromeda was millions of light-years away from our galaxy. It was a groundbreaking discovery. It demonstrated that the cosmos was much bigger than anyone had thought. With an infinite number of galaxies, humanity's perception of the universe was permanently altered when the Andromeda Nebula was reborn as the Andromeda Galaxy. It takes about 2 million years for its light to reach us. The Andromeda Galaxy is not how it is today, but rather as it was over 2 million years ago. Long before the first people set foot on Earth, every particle of light that reaches our eyes started its journey. The record of ancient suns was carried by that light as it traveled across the silent, frigid void between galaxies. It's possible that some of those stars have already dimmed, imploded, or changed into black holes and white dwarfs. Nevertheless, their radiance persists unhindered. Seeing Andromeda is like traveling across time. The light that enters our telescopes now started its journey when modern humans' ancestors were making stone tools and observing far-off fires on the African savanna. As a result, every sight of Andromeda is a calm moment of connection to the distant past as well as a scientific act. Its brightness, which has remained constant over time, is a message from the past. It is moving incredibly quickly toward the Milky Way. Andromeda is hurtling toward us at a pace of more than 200 kilometers per second, despite the fact that it appears still and peaceful in the night sky. By examining the light that its stars emitted, astronomers were able to identify this motion. The light's small shift toward the blue end of the spectrum indicates that the galaxy is getting closer. Since most galaxies are retreating as the universe expands, this phenomenon, known as blue shift, is unique among galaxies. Drawn by the enormous pole of gravity between the two big systems, Andromeda is one of the few planets traveling straight toward us. The approach is taking place very slowly, over billions of years, and is invisible to our eyes. However, it is unrelenting. This cosmic drift, which is already ingrained in space's velocity, cannot be stopped by anything. The future of our galaxy and the gradual dance of gravity that forms the cosmos are both visible in this silent advance. Its collision route has already been charted by astronomers. Scientists have made remarkably accurate measurements of Andromeda's velocity across the sky using satellite observatories like Hubble and GIA. These measurements show that it is stuck on a direct route toward the Milky Way rather than just passing by. Long into the future, computer simulations follow this path, demonstrating how gravity will push both galaxies into bright tidal streamers prior to their eventual merger. In about 4 billion years, there will be the first close encounter. This will be followed by a slow spiraling union that may take billions more to complete. Any surviving world's night skies will change during that period, with enormous star arcs extending over the horizon. The rules of physics have provided humanity with a vision of its far future through the mapping of this collision. On the vast time scale of galaxies, it is a silent but inevitable fate that waits quietly. A new galaxy will be created when it unites with the Milky Way. The Milky Way and Andromeda galaxies will eventually merge slowly and gracefully over billions of years rather than exploding. Gravity will draw them together, causing their spiral arms to twist and stretch into great rivers of starlight. Because of the enormous distance between them, the majority of stars will never directly collide. Instead, their paths will change, creating new orbits inside the expanding system. The two galaxies will eventually merge to form a single massive elliptical galaxy with wide diffused borders and a brilliant, dense core. Stars from both systems will mix across the heavens, filling the sky with brilliant light from any planet that survives. With the merging of two massive spirals into a single glowing whole that will persist long after the Milky Way's original form has vanished, this merger will signify the next phase in the history of our universe. We could refer to the future galaxy as Milkda. The galaxy that will result from the merging of the Andromeda and Milky Way galaxies has already been given a name by astronomers. They refer to it as Milkomda, a combination of the two names that encapsulates the common heritage of both systems. This new galaxy will probably span hundreds of millions of light years and have several trillion stars. At their core, the two galaxies' super-large black holes will drift together and spiral inward until they collide, releasing an enormous amount of energy. Mecha will be a spherical, smooth galaxy with a dazzling glow in the center. Any viewer from a distance will see it as a serene, symmetrical tribute to the forces that constructed it. The combined history of two galaxies that previously faced each other across the dark will be contained within its light. It serves as a reminder that nothing is static and that everything is constantly changing, even in the stillness of space. Hundreds of thousands of light years are covered by its spiral arms. One of the biggest spiral galaxies ever measured is the Andromeda galaxy. From edge to edge, its disk extends over 200,000 light years. Large lanes of stars, gas, and interstellar dust are formed by the spiral arms that wind outward from a luminous center bulge, defining its beauty. These arms are dynamic waves of density that travel around the galaxy like tides rather than stationary structures. These waves compress the material as they pass through gas-rich areas, causing star formation bursts that illuminate the arms with clusters of young blue stars. Darker bands of dust between them scatter and block light, giving the structure depth and contrast. It is possible to observe how matter flows, collapses, and renews itself over enormous timescales by using huge telescopes to observe these arms. The narrative of how galaxies survive while being permanently altered by the gravity that holds them together is revealed by the delicate balance of chaos and order within those spirals. The Andromeda galaxy is far larger than our Milky Way. Andromeda's size is nearly unimaginable when observed through a telescope. Its vast disk is almost twice as large as our Milky Way, spanning more than 220,000 light-years from end to end. It has more than 1 trillion stars, and its dim aura stretches even farther, gradually disappearing into the cosmic void. Andromeda would appear to be several times wider than the moon in our night sky if we could see its entire light. Its enormity serves as a reminder that galaxies are vast cosmic cities composed of innumerable suns, nebulae, and clouds of invisible stuff rather than neat spirals of light. When compared to Andromeda, our Milky Way seems like a tiny brother circling within the same star family. Both galaxies are bonded by gravity and will eventually unite in a spectacular cosmic union. The light of billions of old suns emanates from its center. There is a bright, compact area at the center of the Andromeda galaxy that is brighter than nearly every other place in its enormous disk. Here, the light is golden and gentle, the total brightness of innumerable stars that have been burning for billions of years. The majority of them are little and steady, their fuel gradually dwindling, and they are older than our Sun. In certain areas, these old stars are so close to one another that they are only a few light years away. Light takes about 2 million years to reach us from that busy hotspot. The golden hue of the core indicates to astronomers that it contains an older stellar population where the frenetic generation of new stars has long since subsided. Andromeda's heart glows softly over the eons, resembling a living fossil, a preserved reminder of its earliest days. At its core, there might be an extremely large black hole. Researchers looking into the core of Andromeda have found stars spinning at startling speeds around an invisible object. A gigantic black hole that is millions of times larger than our Sun is the only hypothesis that can account for the data. Even light cannot escape once it passes through the black hole's border due to its extreme gravity. For billions of years, stars have been dancing in tight orbits around it, forming a gravitational ballet. Swirling disks of hot gas and dust, shining brightly as they spiral downward, are probably present in the area surrounding this black hole. The motion of neighboring stars and the radiation emitted by its surroundings can be used to deduce the existence of the black hole, even though it is undetectable to the human eye. It is a silent gravitational engine that shapes the Andromeda galaxy's core and affects the rhythm of everything in its path. There may be 2 black holes there that are trapped together. According to some astronomers, discovered something strange when they used high-resolution tools to study Andromeda's very center. There were 2 bright spots that produced the light rather than just one. This gave rise to the theory that Andromeda may contain 2 very large black holes circling one another in a gigantic slow dance. Such a pair would be the remains of a long-ago galactic merger in which the center black holes of 2 ancient galaxies collided and started to spiral together. They might get closer over cosmic time, creating gravitational energy waves that reverberate throughout space. They might eventually combine to form an even bigger black hole. If confirmed, this secret alliance in the center of Andromeda provides a window into the future of our own galaxy, because there is a gigantic black hole in the Milky Way that could eventually meet its Andromedan counterpart in a bar. A cosmic embrace like that. The vast halo of the galaxy is imperceptible to the unaided eye. A huge, hazy halo that extends far into space surrounds Andromeda's brilliant spiral disk. It is largely made up of thin gas, dispersed dust, and dark matter, and is undetectable to human eyes. This halo is several times larger than the visible part of the galaxy itself, extending over 1 million light-years from the galaxy's center. Ancient star clusters and streams of stars left behind by long-gone galaxies hover within this massive envelope. Scientists use X-ray and ultraviolet measurements to trace the tiny traces of atoms generated by far-off starlight in order to understand the halo. Despite being ethereal, the halo is essential to Andromeda's structure, since it serves as both a border defining the extent of its effect and a repository of cosmic material. It is the unseen but potent ghostly aura of the galaxy, slowly merging with the cosmic medium that permeates the space between galaxies. We could already be in contact with this halo. Over 2 million light-years of apparent emptiness divide the Milky Way and Andromeda. However, new findings indicate that their outer halos may overlap. This indicates that the two galaxies are already in communication through the tenuous plasma and dark matter that surround them, rather than through visible stars. Long before the galaxies themselves meet, it seems as though two unseen atmospheres have started to combine. This contact may get more intense over time, transferring particles and energy across the void. The notion that our galaxy is already in contact with another, even if just slightly, alters our perception of the universe. It demonstrates how borders in space are rarely clear-cut or crisp. Rather, long before the drama of a real collision starts, galaxies merge and affect one another, whispering their existence through dim glows that span millions of light-years. The disk of the galaxy is distorted like a ripple in a pond. Astronomers found that Andromeda's disk is not exactly flat after mapping the stars and gas within it. Rather, it twists and bends like a frozen wave. Parts of the disk are lifted thousands of light-years above and below the center plane by the faint but massive warp. These distortions frequently happen when a galaxy's structure is pulled and bent by gravitational collisions with neighboring galaxies. According to the pattern, Andromeda's serene spiral arms conceal a more tumultuous past. Evidence of past collisions, gravitational tides, and slow majestic motion can be found beneath their elegant design. We can see the ripple of those past interactions frozen into the stars themselves, even at cosmic distances. A reminder that in the turbulent ocean of the history of Cosmos, no galaxy, no matter how calm it seems, is ever really tranquil. It's possible that previous galactic collisions generated the warp contrary to popular belief. Galactic collisions are not violent. Although direct collisions between stars are rare, their combined gravitational pull can change entire galaxies. Astronomers believe that Andromeda's distorted disk and weak star streams are remnants of these interactions. Smaller galaxies may have drifted too close in the past and been ripped apart by Andromeda's tremendous pull. Their stars were dispersed into enormous loops and ripples as their remains were absorbed. Similar to how a pond's surface ripples after a stone falls, the galaxy's disk, which had previously been flat, started to flex under the gravitational tension. These distortions solidified into the current shape over billions of years. Scientists may recreate the history of Andromeda's mergers by examining the pattern of this warp, tracing the spectral footprints of galaxies that disappeared long before life on Earth originated. There are numerous smaller companion galaxies within the galaxy. Andromeda does not exist in a vacuum, just like our own Milky Way. Satellite galaxies are a group of smaller galaxies that orbit it at different distances. Even with powerful telescopes, some are faint smudges of white, while others are bright and distinct. These companions include star clusters that may have once been separate galaxies, and dwarf galaxies that are rich in old stars. Andromeda's powerful gravitational pull shapes their orbits, gradually pulling them inward over time. Astronomers can learn a lot about the growth of massive galaxies from these companions. Andromeda has assembled them into its gravitational family through innumerable encounters and slow mergers. As a result, the sky surrounding it is not empty, but rather alive with motion, with smaller galaxies silently circling their enormous neighbor. Many of those friends are gradually being devoured. The stars and plasma in Andromeda's smaller satellites start to expand and disperse as the galaxy's gravity tugs on them. Long tidal streams that spiral toward Andromeda's main body are formed when the weaker galaxies lose their shape over millions of years. Galactic cannibalism is one of the most prevalent stories in the cosmos, but it is a gradual and silent process. Galaxies expand as a result of it, absorbing the material of their neighbors. Observations have revealed faint arcs and streaks of stars surrounding Andromeda. Each one is the eerie relic of an eaten companion. The light from those streams tells a tale of creation through destruction of small galaxies sacrificed to build a larger, more complex whole. Even now, somewhere within Andromeda's immense halo, new streams are developing as tiny galaxies yield to its pull, feeding the ceaseless cycle of cosmic evolution. Some of its stars were born outside and later captured. Not all the stars that now belong to Andromeda were born there. Many began life in smaller galaxies that later merged with it or passed too close to resist gravitational pull. The stars in these smaller systems were thrown into new orbits inside the halo and disk of Andromeda when they broke apart. By examining their chemical makeup, which bears the signature of their initial birthplace, astronomers are able to identify these foreign-born stars. Some are poorer in heavy elements, designating them as ancient wanderers from primitive galaxies. Together, they demonstrate that Andromeda's expansion has been a collaborative process, shaped by several generations of mergers. Each new addition has brought its own history and its own stars, forming a great galactic tapestry that tells a story not of one beginning, but of many threads joined over time and space. As a result of galaxies being engulfed, streams of stars follow. Long, dim starlight trails wind through Andromeda's outer regions. These star streams are the leftovers of smaller galaxies ripped apart by gravity and absorbed into Andromeda's mass. Some span across hundreds of millions of light-years, tracing the exact pathways those lost galaxies originally followed. Astronomers can recreate the timeline of Andromeda's numerous mergers by examining their form and speed. Every stream is a fossilized record of an event that influenced the structure of the galaxy. Because the courses of these streams curve in accordance with the invisible gravitational landscape surrounding Andromeda, they also aid in revealing the existence of dark matter. They glimmer softly in the dark, mute witnesses to billions of years of cosmic history. But despite their fragility and faintness, they are among the galaxy's most exquisite features. Its structure reflects a history of cosmic cannibalism. The more we learn about Andromeda, the more proof there is that it has constructed itself through many acts of cosmic eating. Its halo contains stars of many origins. Its outlying regions glisten with faint debris from galaxies it has swallowed, and its disk is wrinkled and distorted, a lengthy evolutionary journey influenced by merger after merger is indicated by each indication. Today, astronomers view Andromeda as the collected remnants of numerous smaller galaxies, rather than as a single entity. These interactions may have even changed the form of its spiral. The remainder is composed of an invisible substance that neither emits nor absorbs light. It is referred to by astronomers as dark matter. Its gravitational pull, which keeps the galaxy together and modifies the speed of its stars, is the sole way that its existence is made apparent. The outer portions of Andromeda would disintegrate in the absence of dark matter. Our knowledge of the universe is called into question by the notion that the majority of a galaxy's mass is invisible. Exotic particles that only interact through gravity could make up dark matter. Alternatively, it can be an indication of deeper, as yet unidentified physics laws. Whatever it is, dark matter envelops Andromeda like a huge transparent cocoon, influencing its destiny and connecting it to every other galaxy in the universe, via the invisible web of gravity that unites everything. There are vastly more dark matter particles than visible stars. Only a tiny percentage of Andromeda's total mass is made up of its bright stars and gas, according to scientific calculations. The remainder must be dark matter, which may dominate the visible components by a factor of 10. This invisible material affects the galaxy's rotation by creating a halo that stretches well beyond the spiral arms. The outer stars would travel far more slowly without it. Rather, a vast hidden presence is shown by their fast speeds. Galaxies get their stability and structure from dark matter, which functions as a cosmic scaffold. Although it cannot be immediately detected, its effects are ubiquitous. In this sense, Andromeda is both a great gravitational riddle and a grouping of stars. Its bright disk hovers amid an invisible sea of matter, serving as a constant reminder that most of the cosmos is still hidden from human view. Its star's motion indicates the existence of that invisible mass. Astronomers find something startling when they measure the speed at which stars orbit Andromeda. Despite having much less observable substance to tug on them, the outermost stars orbit nearly as fast as those close to the center. This implies that the extra gravity required to keep the galaxy together must come from something invisible. Dark matter is thought to be responsible for that unseen power. Scientists can determine the distribution of this invisible material throughout the galaxy by tracking the rotation speeds at various distances from the core. Andromeda is surrounded by a huge black halo that extends well beyond the apparent spiral, as seen by the star's steady, smooth motion. Andromeda is now one of the best examples in the universe for comprehending how dark matter shapes the grand architecture of galaxies. Thanks to meticulous study, large areas of Andromeda are covered in incandescent hydrogen gas. Massive clouds of hydrogen, the raw material used to create new stars, are located throughout Andromeda's spiral arms. This gas glows weakly in pink and red hues when it is energized by starlight, creating nebulae that span thousands of light years. Sites of active star formation are indicated by these bright areas. Denser gas clusters are drawn together by gravity within them, until they ignite as new suns. Astronomers can witness Andromeda's continuous life cycle in action by observing these hydrogen clouds. Creation has continued even in such a huge and ancient cosmos. A window into Andromeda's past and present is provided by the light from these nebulae, which takes almost 2 million years to reach us. The splendor of these luminous clouds serves as a reminder that new light is constantly emerging, even in the quiet depths of space. New stars are born in these areas, which serve as nurseries. Tiny gas pockets collapse due to gravity within Andromeda's massive hydrogen clouds. A star is created when nuclear fusion ignites due to an increase in temperature and pressure. These star nurseries are delicate and chaotic, with dark dust lanes weaving through them like smoke and blazing gas. A large number of these young stars grow in clusters, illuminating their surroundings with scintillating hues. Their strong radiation and stellar winds gradually mold the gas into complex forms, creating filaments and voids. A few of these newborn stars are big and transient. In a few million years, it will explode as a supernova. Others will continue to shine for billions of years. Astronomers may see the identical mechanism that previously produced our Sun by studying these Andromeda regions, acting as a reminder that the cycle of cosmic birth is ongoing throughout the cosmos. Massive hot gas bubbles extend much above its disk. Astronomers have found enormous hot gas bubbles, each tens of thousands of light-years large, far above Andromeda's spiral arms. These enormous structures emit X-ray radiation, which is proof that the galaxy's core and star-forming areas have released tremendous amounts of energy. They might have been created over millions of years by strong star wind bursts or waves of supernova explosions that forced gas outward. By releasing matter and energy into the surrounding halo, these bubbles function as a sort of galactic exhale. Examining them shows how galaxies control their own development, striking a balance between creation and release. These enormous shapes, which breathe motion and heat into the silent darkness, signify Andromeda's dynamic life. Even though they are invisible in regular light, they demonstrate how even a galaxy is capable of pulsating and changing, leaving enormous marks on the surrounding universe. It's possible that intense starbursts produced the bubbles. Andromeda occasionally goes through periods of sharp increases in star production. The galaxy is overloaded with energy during these occurrences, which are referred to as starbursts. Hot gas is driven outward by the winds and explosions of enormous newborn stars as they quickly form and perish. Giant bubbles that grow far above and below the cosmic plane are the outcome. Each of these bubbles carries material back into the galaxy's halo, leaving behind traces of Andromeda's most intense times. Heavy elements created inside stars gradually enrich the surrounding atmosphere, supplying the components for upcoming light generations. These bubbles' presence demonstrates that galaxies are dynamic ecosystems that breathe, burn, and regenerate. Like other galaxies, Andromeda is surrounded by weak structures that contain the memory of past eruptions. Its interstellar medium is constantly changing because of supernova explosions. Individual stars in the Andromeda galaxy exist in silence for billions of years. However, occasionally one of them collapses spectacularly into a supernova. In a single moment, these enormous explosions discharge more energy than our Sun will output in its lifetime. Over the course of cosmic time, thousands of similar occurrences have taken place in Andromeda. The interstellar medium of the galaxy is stirred and enhanced by each of them. These explosions produce shockwaves that spread outward, squeezing surrounding gas clouds and igniting fresh star formation waves. Heavy elements created at the core of dying stars, such as iron, gold, and oxygen, are launched into space and end up on unformed future worlds. Andromeda's composition and structure are continuously replenished through this cycle of death and rebirth. This ancient pattern of cosmic evolution is the foundation of its radiant brilliance, which can be seen from millions of light-years afar. Thousands of young blue stars shine in its spiral arms. Andromeda's spiral arms shimmer with the brilliant sapphire glow of young stars when viewed in full color via telescopes. Massive, intense, and short-lived, these youthful suns burn fiercely for only a few million years before fading into supernova. Within enormous clouds of hydrogen gas, where gravity draws matter together until fusion starts, they develop in clusters. Their surroundings are flooded with ultraviolet light, which highlights Andromeda's arms' elegant design and makes surrounding gas shine. The locations where the galaxy is still creating new light are represented by these blue stars, which are indicators of its continuous creativity. Despite their short lifespans and early deaths, they shed light on the galaxy's ongoing evolution. The energy of cosmic youth is dispersed across the night when we look at Andromeda's radiant spiral arms. Every blue point represents a fleeting, dazzling moment in an old tale. Older red and yellow stars cover its center, a world that contrasts with the bright spiral arms of the Andromeda galaxy is located at its center. The stars blaze in gentle shades of crimson and gold here, and they are older and colder. These ancient suns now glow more softly, their light constant but muted, having long since depleted much of their hydrogen fuel. they work together to provide the warm amber glow that dominates the center bulge of Andromeda. This area has seen a slowdown in star formation over billions of years, leaving behind a dense, stable population that travels in intricate orbits around the galaxy's hidden black hole. Astronomers can learn more about Andromeda's early past by examining its center cluster, which reveals what remains after the storms of star creation have passed. The contrast between the golden center and the vivid blue arms offers a tale about time itself, showing how galaxies grow older, mature, and eventually settle into calm brilliance as their energy progressively wanes. The disk's star generation is not consistent. The spiral structure of Andromeda may seem symmetrical, yet star creation happens unevenly within it. While some areas are rather dark and dormant, others are blazing with clusters of recently formed stars. The distribution of gas, dust, and magnetic fields throughout the galaxy's disk shapes this variation. Gravity can easily cause new starbirth bursts in regions where cold hydrogen is prevalent. In other places, the gas can be too hot or too thin to collapse. Stars are ignited along narrow, curved bands when waves of density produced by spiral arm motion travel around the disk and compress the gas in periodic cycles. Astronomers can learn more about how galaxies breathe and create stars in pulses rather than continually by seeing these patterns. Even on a galactic scale, creation occurs in intricate cycles, with serene areas counterbalancing the bright explosions of cosmic energy that define its spiral, as Andromeda's uneven light tapestry demonstrates. Beauty. While the edges continue to shine, the core areas have slowed. The raw material needed for star formation has steadily been depleted in the Andromeda galaxy's center regions. The majority of that gas has either formed stars or been expelled by previous stellar winds. Because of this, the inner disk is now mostly illuminated by older, longer-lived stars, whose light is consistent but muted. On the other hand, new stars can continue to develop distant from the center because the galaxy's outer regions are still rich in cold hydrogen gas. Because of this distinction, Andromeda has a sort of temporal layering where a young rim and an ancient heart coexist. Astronomers can follow the evolution of galaxies from active star-forming systems into more tranquil, mature structures by examining this disparity. Andromeda's glowing edges serve as a reminder that even an aging galaxy can have pockets of life where the cosmic cycle of rebirth and rebirth silently continues amid the outermost arms. Like hazy ribbons, dust lanes wind between the spiral arms. The bright arms of Andromeda are streaked with complex dark lines when observed through large telescopes. These are lames of interstellar dust made up of microscopic carbon and silicon grains that have been left behind by dead stars. They give the illusion of smoky ribbons winding through the bright spiral by absorbing and dispersing starlight. The chilly, dense areas where stars are created are found within these dust lanes. They are the galaxy's rich soils, not just shadows. Their intricate forms show how matter moves and accumulates along the spiral arms, tracing the motion of gas under Andromeda's gravity. These lanes come to life when viewed in infrared light, absorbing radiation from neighboring stars and shining slightly with warmth. We get a glimpse of the silent choreography of cosmic creation through their intricate patterns, the identical mechanism that created the sun, the earth, and all known life's atoms. These dark lanes are visible through infrared telescopes, faintly burning with heat. The dust lanes of Andromeda appear as shadows against the light of the stars to the unaided eye or via standard optical telescopes. However, The shadows disappear and are replaced by a gentle, bright glow when astronomers observe in the infrared. Only at longer wavelengths can one discern the modest heat emitted by the dust itself, which has been warmed by surrounding starlight. Young stars, still enveloped in their birth clouds, can be discovered by astronomers using infrared observatories like the Spitzer and James Webb Space Telescopes. By demonstrating how gas and dust combine to produce Andromeda's spiral pattern, these photographs unveil the planet's hidden architecture. A tapestry of soft warmth replaces what appeared to be darkness. Every atom carries energy, every shadow conceals light, and every quiet hums with invisible activity, even in the frigid reaches of space, as the view serves as a reminder. Where the younger stars reside is revealed by its ultraviolet brilliance. The Andromeda galaxy emits radiation throughout every electromagnetic spectrum, not only visible light. A different picture emerges when astronomers study it at ultraviolet wavelengths. Massive newborn stars are grouped together in bright, active regions that light up the spiral arms. The surrounding atmosphere is heated and shaped by the enormous amounts of UV energy that these young stars release. Scientists can track the galaxy's most active star-forming regions and gauge how quickly new stars are still being formed by mapping this glow. Andromeda's interior structure of star nurseries, flickering like embers within the spiral, is visible in the ultraviolet image, which gives the galaxy an almost skeletal appearance. Every brilliant area is a cosmic cradle that is younger than a few million years. Seeing Andromeda in UV light allows one to observe its life and breathing in real time. It serves as a reminder that even very old galaxies are still producing new light with consistent, patient energy. Cold gas that is about to collapse into stars is revealed by radio waves. Large clouds of cold hydrogen serve as the raw material for nascent stars long before they ignite. Although these areas don't shine in visible light, astronomers can use enormous radio telescopes to detect the weak radio signals they send. Scientists are able to map the location of neutral hydrogen in Andromeda by tuning to its particular frequency. The resulting image demonstrates that Andromeda's structure extends far into space by revealing massive spiral patterns that reach well beyond the observable disk. This chilly gas, which will eventually collapse under gravity to produce new suns and planets, is the galaxy's storehouse of future starlight. Astronomers can forecast the location of the next generation of stars by watching it. As a result, Andromeda's radio perspective serves as a kind of future template, a silent, unseen base awaiting the dazzling stars that will eventually illuminate its arms once more. Andromeda is radiant in all light wavelengths. The Andromeda galaxy emits light in every electromagnetic spectrum, from radio to gamma rays. A new aspect of its story is revealed by each wavelength. Infrared light displays the warmth of dust and newly born stars, while radio waves reveal its massive structure and chilly gas. The big spiral itself is visible in light. X-rays reveal the furious remains of burst stars, whereas ultraviolet detects areas of high energetic youth. When combined, these layers create a comprehensive image of a complex galaxy. The truth cannot be fully revealed by a single viewpoint. Astronomers can only fully perceive Andromeda's personality, from the serene outer disk to the ferocious energy close to its core, by integrating all of these wavelengths. Seeing it is like looking at the whole range of cosmic life, from conception to death, all interwoven into one enormous celestial work of art from beyond space. It is among the universe's most researched galaxies. Andromeda has been observed for several hours by orbiting observatories. while sensors on board the James Webb Space Telescope and the Chandra X-ray Observatory have studied its dusty fringes and active center in fine detail, the Hubble Space Telescope has obtained sweeping panoramas of its spiral structure. Andromeda is a close laboratory for studying galaxies around the universe. Because of its proximity to and structural resemblance to our Milky Way, it enables researchers to examine processes that would be difficult to clearly discern in systems that are farther away. Every image and every wavelength contributes to our understanding of how galaxies interact, age, and live. Andromeda is not just a far-off speck in the night sky. It is a pillar of contemporary astronomy and a standard by which we gauge our understanding of the cosmos and our role in its vast scheme. The question of whether it was inside our Milky Way was hotly contested by early astronomers. Nobody was confident about Andromeda's true nature before the 20th century. It looked like a faint, hazy spot via early telescopes. The Great Andromeda Nebula is another name for it. It was thought by many astronomers to be located within our own Milky Way, a close cluster of mist-covered stars. Others speculated that it might be something far bigger, possibly an island universe that exists outside of our own. This argument turned into one of the most heated discussions in astronomy history. The reality was concealed in the absence of accurate tools for measuring distance. Andromeda was both familiar and enigmatic for ages, visible to the naked eye but unfathomable in scope. The debate about its nature was a reflection of people's increasing interest in the cosmos and their desire to know if our galaxy was special or a part of something bigger. This ambiguity lasted until one observation definitively resolved the issue. The dispute was ultimately resolved by a well-known photo. Astronomers started taking long-exposure pictures of the night sky from the beginning of the 20th century. Edwin Hubble used the Hooker telescope at Mount Wilson Observatory to capture one of these pictures, which showed something remarkable inside the Andromeda Nebula. Cepheid variable stars were weak, pulsating spots of light embedded in its brilliant spirals. Hubble was able to determine their distance by monitoring their brightness and pulse rhythm. The outcome was astounding. These stars were located far outside of our Milky Way. The Andromeda Nebula was a massive galaxy in itself, not just a local cloud of gas. Astronomy was irrevocably altered by that one image, which turned a mystery into a revelation. By demonstrating that our galaxy was just one of innumerable others dispersed throughout the vast fabric of the universe, it helped humanity realize the actual scope of the cosmos. Edwin Hubble demonstrated that it was much beyond the boundaries of our galaxy. Edwin Hubble determined that Andromeda was over 2 million light-years away using the light from Cepheid variable stars. Such a distance was practically unthinkable at the time. The long-held notion that the Milky Way contained all of creation was disproved by the discovery. As the first confirmed galaxy outside of our own, Andromeda serves as a glimpse into the immensity of the cosmos. Modern extragalactic astronomy began with Abels's exact measurements. In addition to illuminating Andromeda's actual nature, his research suggested that space was teeming with galaxies of all sizes and shapes that extended indefinitely in every direction. This discovery changed how humans perceived their cosmic home. We realized for the first time that we were a part of a vast, expanding cosmos, with many other worlds shining in the dark, that finding permanently altered our comprehension of the cosmos. The scientific community was astounded when Edwin Hubble revealed his discoveries in the 1920s. Until then, the majority of astronomers thought that the Milky Way was a representation of the entire universe. The known cosmos was stretched by an almost unfathomable amount when it was discovered that Andromeda was a galaxy located far beyond our own. The universe suddenly expanded from a solitary star island to a huge ocean with innumerable galaxies. This revelation changed our understanding of scale, time, and potential, and transformed humanity's role in the universe. The realization that the cosmos is expanding was also made possible by it, a notion that still influences cosmology today. As a result, Andromeda came to represent perspective and serve as a reminder that even the most well-known area of the sky might hide marvels beyond comprehension, just waiting for human curiosity to become keen enough to notice them. It signaled the realization that the Milky Way was not the only galaxy. Before Hubble's research, people thought that every star in the night sky belonged to our own galaxy, that was permanently altered when it was discovered that Andromeda was a completely different galaxy. It implied that the Milky Way was only a part of a much wider cosmic society. The cosmos abruptly changed from being a single city of stars to an endless archipelago with galaxies as its islands. With this realization, astronomy evolved from a study of our immediate environment to an investigation of the universe. Generations of visionaries and scientists have been motivated by it to see beyond the boundaries of our own spiral arms. We are reminded of that pivotal moment when the limits of the known world vanished and the universe opened up in front of us, beckoning us to continue exploring indefinitely every time we see Andromeda rising in the fall sky. The vastness and expansion of the universe were made evident by the Andromeda galaxy. Edwin Hubble carried out more research by observing other far-off systems after learning that Andromeda was a distinct galaxy. He saw that most of them were going away from us since their likes were extended toward the red end of the spectrum. One of science's most important findings resulted from this discovery: the cosmos is growing. But Andromeda was a rare exception, heading in our direction rather than away. Its method gained even greater significance by demonstrating that galaxies are dynamic actors in a vast cosmic motion rather than static dots in space. Astronomers were able to determine velocity and distance using Andromeda. Scientists are able to determine their distance with astonishing accuracy by comparing that intrinsic brightness to how faint they look from Earth. Andromeda was the first important step in what became known as the cosmic distance ladder. These stars are the source of all measurements of galaxies, clusters, and the expanding cosmos. In addition to revealing Andromeda's enormous distance, the light from its Cepheids provided scientists with the means to map the whole universe. In this way, the scale of the universe was initially determined by the stars of our closest neighbor. Even now, their constant pulse continues to direct our investigation of the limitless. For that measurement, Andromeda's Cepheid variable stars were essential. Cepheid variables are exceptional stars that exhibit a precise repeating pattern in their brightness fluctuations. The intrinsic luminosity of the star directly affects how long each cycle lasts. Astronomers can calculate the star's actual brightness and, consequently, its distance by observing that rhythm. Edwin Hubble discovered that Cepheid variables were much too faint to be found in our own Milky Way when he discovered them in the Andromeda galaxy. That realization demonstrated that Andromeda was a distinct galaxy, far farther away than anyone had previously thought. As a result, these stars served as the basis for cosmic measurement, enabling researchers to estimate distances in space. We were able to map the universe one beat at a time thanks to their steady pulses, which transformed light itself into a language of geometry and time. Every cycle is a heartbeat that reverberates through intergalactic space's darkness. Their vivid pulses show how far away they are. Over millions of light-years, every Cepheid variable in Andromeda functions as a small, flashing beacon. The star brightens and dims in a constant pattern as its surface grows and compresses. Astronomers can measure the star's actual luminosity by capturing that pulse. Its distance can be calculated by comparing that intrinsic brightness to the weak light that reaches Earth. This technique was the key that opened the universe's scale. Our galaxy is just one among billions, as evidenced by the finding that these stars in Andromeda were so far away. In order to measure galaxies far beyond Andromeda, the same method is still employed today, but it has been improved by contemporary telescopes over cosmic time. These stars keep up their silent beat. Arriving as a constant message from the past, their light tells us not just where they are, but also how far human understanding has come since we first saw them. The fact that Andromeda is millions of light years away was verified by their light. Edwin Hubble discovered that the Cepheid variable stars in the Andromeda galaxy were much fainter than they would be if they were in our own Milky Way. Distance was the only reason. Millions of light years is an almost unfathomable distance. Long before people set foot on Earth, that dim light had been making its way toward us through the silent emptiness between galaxies. A Cepheid star's actual brilliance and distance were precisely revealed by each flickering pulse. The outcome of Hubble's comparison of the two was indisputable. Andromeda was a huge island of stars that existed well beyond the boundaries of our galaxy, not just a nearby nebula. This insight fundamentally altered our perception of the universe by showing that it was much larger than anybody had ever imagined, and that light itself might act as the ultimate messenger between worlds that were separated by vast distances in both space and time. The universe suddenly grew substantially larger as a result of that discovery. Astronomers thought the Milky Way encompassed everything before Edwin Hubble's measurements. The known cosmos instantly grew when his calculations revealed that Andromeda was millions of light years away. The Milky Way was now one of many galaxies floating through space rather than the entirety of creation. From thousands of light years to billions, the scale of existence expanded. The finding changed perception as well as science. Humanity came to understand that it lived on a little planet around a small star in a single galaxy, which was a speck in an infinite universe. The Andromeda insight turned into an epiphany, similar to when mankind first realized that the Earth rotates around the Sun. Every dim glow in the sky could be another galaxy, home to countless stars and worlds beyond. And the cosmos was no longer a singular structure, but rather an endless canvas full of possibilities, creativity. The Andromeda galaxy is approaching us at a speed of more than 200 kilometers per second. Andromeda is traveling inward, in contrast to the majority of galaxies that drift away as the universe expands. It is getting closer, as evidenced by measurements of its brightness showing a little shift toward the blue end of the spectrum. Over 200 kilometers per second is an incredible pace. Even though it sounds quick, the collision won't happen for billions of years since our galaxies are so far apart. The reciprocal gravity between our two huge systems, each gently dragging on the other across space, is what propels Andromeda's journey. This strategy is unavoidable but not violent, a portion of the slow dance that controls the galaxies in the local group. Their halos already start to overlap as they get closer, mixing dark matter and invisible gas. The first tiny indication of our connection is the little blue tint in Andromeda's brilliance. That Andromeda's and our futures will inevitably collide on a galactic level. Our galaxies will eventually be drawn together by gravity. There is an unyielding pole between the Andromeda galaxy and the Milky Way. Despite the universe's overall expansion, their mutual gravity pulls them closer over billions of years, like a sluggish but steady tide. The two galaxies will start to merge in about 4 billion years, their gas clouds and stars interacting in a massive cosmic dance. Their spiral arms will be stretched into enormous light arcs by gravity, creating new patterns. This is a normal aspect of galactic evolution rather than an uncommon occurrence. For billions of years, collisions such as these have altered the cosmos, turning smaller galaxies into larger, more complicated ones. It will be a metamorphosis rather than a disaster when Andromeda and the Milky Way collide. A beautiful, slow-motion convergence that will transform both into something quite different, bound indefinitely as a single magnificent edifice that shines brightly deep within the night of the future cosmos. Seldom will stars collide with one another. Even though there are hundreds of billions of stars in both the Milky Way and Andromeda, the distances between them are enormous. There would be very little likelihood of any two stars colliding directly if two galaxies were to totally overlap. The collision would be gravitational instead. The combined gravity of both galaxies will cause the star orbits to change and bend. While some will settle into new courses around a common center, others will be launched into vast tidal tails that span thousands of light years. On the other hand, gas clouds will collide and compress, causing star formation bursts that will add new light to the sky. The event will be one of restructuring rather than devastation. It will appear to a far-off observer as two glowing spirals embracing one another and gradually fusing into a single radiant entity that shines peacefully in the vast and unending darkness. Rather, their orbits will merely change and reshape. Gravity will sculpt a completely new celestial landscape when the Andromeda galaxy eventually collides with our own. In the combined gravitational field, stars that previously orbited in stable circles will start to follow graceful looping paths. Some might be ejected into enormous arcs that extend past the boundaries of the combined system. Others will collapse inward, creating a brilliant, dense core. The two spiral patterns will eventually lose their symmetry and become one long structure. The distribution of mass within the merging galaxies will eventually direct the motions of billions of stars into new orbits. According to simulations, the system will settle back into harmony following the initial encounter's disruption. From inside that future galaxy, the night sky will be completely changed, with streams of light tracing the history of two galaxies that merged into one. The Earth's night sky in the future will be magnificent. In billions of years, if mankind or its ancestors are still around, they will see an unparalleled cosmic extravaganza. Andromeda will expand and brighten in the night sky as it gets closer, changing from a faint smudge to a bright, expansive disk. Its spiral arms will eventually be visible to the unaided eye, casting exquisite light arcs across the heavens. Glowing streams of stars that spread across space like rivers of fire will dominate the sky during the merger. From Earth's surface, the view will be both surreal and magnificent, a display unfolding over millions of generations. Though the process will be slow, its beauty will be unmatched. The stars will not vanish, but rearrange themselves into new constellations. The future night will shimmer with proof that galaxies, like living creatures, are born, develop, and combine, leaving behind stunning signs of their union across the sky. The two galaxies will extend into long tidal streamers of light. As Andromeda and the Milky Way approach one another, their mutual gravity will deform their spiral arms, dragging stars and gas into enormous arcs that trail behind them. These long structures, known as tidal streams, are created by the same forces that cause Earth's ocean tides to rise, but on a scale billions of times larger. Billions of stars strung thin over intergalactic space will make up each stream. Some of these streams will later fall back into the merging center, while others will drift away, becoming thin ribbons of starlight lost to the abyss. Similar streams have been seen by astronomers surrounding other galaxies, providing us with a sneak peek at what our own collision will produce in the future. For billions of years, people will be able to see these bright bridges of light, gentle hints of the gravitational bond that once brought two spiral galaxies together and transformed them into one bright whole. They will eventually unite into a single massive elliptical galaxy. The Milky Way and Andromeda will eventually unite into a stable structure following a protracted series of close encounters, tidal distortions, and whirling collisions. Over billions of years, their orbits will lose their ordered spiral pattern, replaced by a more rounded, elliptical shape. The resultant galaxy will be vast, holding the combined stars, gas, and dark matter of both. Such a system is known as a massive elliptical galaxy, and astronomers have seen numerous instances of it throughout the cosmos. The center black holes of the two initial galaxies may someday combine as well, unleashing waves of gravitational energy that ripple over space-time. The outcome will be peaceful, even though the specifics will take ages to reveal. A huge, blazing spheroid of stars, silently glowing in the darkness of space. This future galaxy has already been given a name by some scientists, Milky, which is a poetic combination of both parents. It might take billions of years to finish that process. The collision and merging of Andromeda and the Milky Way will occur gradually over several billion years, rather than as a single spectacular event. When the galaxies first come into contact, they will pass through each other, go outward, and then be pulled back by gravity for further encounters. Their forms will be increasingly distorted with each pass, forming streams and loops of stars that gradually take on new configurations. Entire generations of stars will be formed and die throughout the lengthy merger process. The smooth symmetry of a single elliptical galaxy will eventually take the place of the chaotic motion. The temporal scale is unimaginable. However, such occurrences are frequent and normal in the universe's rhythm. Two old spirals will be sculpted by time itself into a single, timeless monument of quiet and starlight that spans the abyss. In it, our solar system will probably drift undamaged. The Sun and its planets will most likely survive unaffected, even if the future merger of the Milky Way and Andromeda will drastically alter both galaxies due to the enormous distances between individual stars. The solar system will merely change its location within the new cosmic framework while maintaining its sluggish orbit. It will survive the encounter unharmed, even if it is thrown away from the center or drifts amid strange constellations. The night sky will appear entirely different throughout time. The familiar band of the Milky Way may disappear as its structure changes and new star clusters may emerge. However, the Earth will continue to orbit, the Sun will continue to shine, and there will always be light in the sky. Our tiny piece of the universe will remain warm and alive while the cosmic collision that appears so massive from a distance passes around us almost lightly. We may already be known to extraterrestrial societies in Andromeda. If there are sentient aliens in the Andromeda galaxy, they may have long since focused their telescopes on the Milky Way. They would see our galaxy from the perspective of more than 2 million years ago. Since it takes so long for light from the Sun and Earth to reach them, they might even be able to identify the faint spectral trace of life in our atmosphere if their technology were sufficiently developed. Similar to how we look for biosignatures on exoplanets, they believed that humanity had not yet progressed. All they would see would be a starry, primordial Earth. In a similar vein, we witness Andromeda's far-off history rather than its present. Just as we are gazing back at their past, any civilization there is looking back at a previous iteration of ourselves. The two galaxies are already linked via the eternal interchange of light rather than physical contact. Our galaxy would seem to their astronomers as it did a very long time ago. If astronomers in Andromeda were to use large telescopes to view the Milky Way, they would see our galaxy as it was millions of years ago rather than how it is today. Every observation is also a look backward in time due to the finite speed of light. Even before the emergence of the first animals, they would have seen the Milky Way. Our sun would seem youthful to them, and our galaxy's spiral arms would appear slightly different. Delay is mutually beneficial this time. Our perception of Andromeda is just as old. Thus, the space between times is likewise a distance between galaxies, a lively, lightly written archive of the past. When we look at Andromeda's brilliance, we are peering into history itself, illuminated by stars that shine from long ago rather than across empty space. It would take millions of years for us to communicate with each other. An intelligent civilization in Andromeda would have to send a signal over 2 million light-years across cosmic space if they ever tried to get in touch with us. That message would take more than 2 million years to reach its destination, even at the speed of light. It would take the same amount of time to respond. Both civilizations may have evolved or disappeared by the time the communication reached its second message. Such exchanges are not feasible due to the vastness of space. However, the idea itself is profound. It emphasizes how vast the universe is and how isolated each world is inside it. Every radio broadcast and light beam turns into a sort of time capsule, a whisper sent into the darkness that might eventually be heard by far-off minds in a whole different era. The cosmos continues to be patient and attentive throughout that quiet. There may be habitable circumstances on some of Andromeda's worlds. Numerous planets undoubtedly orbit in temperate zones where liquid water may exist within the Andromeda galaxy's numerous star systems. Statistical models indicate that millions of Earth-like worlds may be dispersed across its spiral arms around stable sun-like stars, despite the fact that we are now unable to directly observe them. It's possible that some of these worlds have kept climates and atmospheres conducive to life. Others might be cloud-covered marine worlds or frozen moons heated by tidal forces. The subtle spectral traces of such locations, which could indicate oxygen, methane, or other indicators of life activity, might eventually be picked up by telescopes of future generations. It pushes the imagination to think that Andromeda may contain entire civilizations of life forms, each beneath its own star. It serves as a reminder that the universe's potential for diversity and wonder is probably greater than anything we have yet learned or even imagined. Others might revolve around strange stars that differ greatly from our sun. Not every star in Andromeda has the comforting warmth of our sun. Some are massive blue giants that are barely a few million years old and emit intense ultraviolet light. Some are tiny red dwarfs that can burn for trillions of years. They are chilly and dim. The ecosystems of planets around such stars would be completely different. A world may experience extreme heat and radiation in the vicinity of blue giants. When a planet is close to a red dwarf, it may be trapped in perpetual twilight, with one side of the planet always facing the star. Certain stars form binary pairs, which result in planets that simultaneously orbit two suns and create double shadows. Andromeda's star diversity guarantees a similarly wide variety of planets. There are countless opportunities for life and exploration across the bright expanse of the galaxy, with each system potentially telling a unique tale of chemistry, atmosphere, and light. In the dark, rogue planets might float between its stars. Not all of Andromeda's planets are associated with a single star. Some are now free to roam the dark, unfettered and alone after being expelled from their home systems following gravitational collisions. With their frozen surfaces and eternally dark sky, these renegade planets glide peacefully between the stars. However, some people may still have residual internal heat or radioactive decay that produces warmth. Some may have hidden refuges for possible microbial life, subterranean waters behind heavy amounts of ice. Andromeda may have trillions of these invisible worlds. According to astronomers' estimates that there may be more rogue planets than stars in a typical galaxy. They are the universe's nomads. Every single one of them is a lone traveler traversing the silent voids between suns indefinitely. Reminders that the cosmos is full of opportunities just waiting to be discovered, even in the dark. Almost every known type of star can be found in the galaxy. There is a remarkable variety of stars in Andromeda's enormous expanse. The galaxy is home to tiny white dwarfs, elderly red giants, dazzling blue supergiants, and extremely fast-spinning neutron stars. The majority of its stellar mass is made up of innumerable weak red dwarfs and enormous populations of regular sun-like stars. A comprehensive laboratory for researching star evolution is provided by this combination of kinds. Astronomers can witness every stage of a star's existence, from its birth within a brilliant nebula to its last moments as a cooling ember, by studying Andromeda. The galaxy's hues are also shaped by the variety of stars, with younger areas lighting blue and older areas glowing red. Each kind of star adds to the rhythm of the galaxy, and when combined, they form a live mosaic of light that symbolizes almost every scenario of stellar existence in the cosmos. It is surrounded by massive clusters of ancient globular stars, hundreds of globular clusters, which are dense, spherical collections of old stars that have been circling the galaxy for billions of years, surround Andromeda's bright disk. Hundreds of thousands of suns are crammed into a region that is only a few dozen light-years across in each cluster. These stars were born during the early stages of the universe, making them some of the oldest stars in the universe. Their motion is steady and calm, and their light is gentle and golden. By examining them, astronomers can gain insight into the earliest periods of galactic history and learn how Andromeda and its partners initially came together. The globular clusters shine subtly along the borders of the galaxy, forming a sort of halo crown around it. They might contain remnants of long-lost systems that were absorbed during Andromeda's development. They are the galaxy's ancient defenders, circling in silence as they have for ages, keeping alive the memory of a period when the first stars appeared. These clusters include some of the biggest ever discovered. A couple of Andromeda's numerous globular clusters are particularly noteworthy. In addition to being the biggest in Andromeda, Mole 2, also known as G1, is among the biggest star clusters ever seen. It is more massive than many tiny galaxies because it is made up of several million stars that are firmly bonded by gravity. G1 shines as a faint point just beyond the edge of the galaxy, so brilliant that it can be observed with small telescopes. The residual core of a dwarf galaxy that Andromeda swallowed long ago, stripped of its outer layers but yet clinging together as a compact sphere of ancient stars, is what astronomers think it might be. Such clusters preserve hints about the formation of Andromeda and the mergers that created it, acting as relics of cosmic history. They show that even in the quiet of a star cluster, there is a light-written tale of creation, collision, and perseverance. Others exhibit odd, unidentified dynamics. Some of the numerous globular clusters that orbit Andromeda exhibit behaviors that are difficult to understand. Their stars spin more quickly or more slowly than gravity alone should permit, exhibiting strange patterns of motion. In certain instances, the thrusters seem to be slightly deformed or stretched, as though they are being pulled by an invisible force. These strange motions, according to astronomers, may indicate the presence of dark matter or the remains of tiny galaxies that were previously a part of Andromeda's early history. These clusters' peculiar dynamics function as remnants of ancient cosmic events. Maybe a nearby collision's passing shockwave or the merging of two clusters. Every cluster has its own narrative. Its motion was captured in the slow language of time and gravity. By examining them, scientists can learn more about Andromeda's evolutionary history and unearth subtle hints about it. It is believed to result from the movement of ionized plasma and the spinning of Andromeda's disk, which work together like a dynamo. These kinds of magnetic fields are crucial to the life of galaxies because they shape interstellar clouds, direct cosmic ray flow, and may even have an impact on the rate at which stars develop. One of Andromeda's most exquisite hidden features, despite being intangible, is its magnetic field, an invisible thread that unites its stars and nebula in a delicate, constantly shifting balance of motion and energy. It might affect how cosmic rays travel through its disk. Cosmic rays are high-energy particles that travel around the universe continuously. These particles travel along the routes that the magnetic field of Andromeda has sculpted. Their mobility is not completely random since the field funnels and reroutes them. Astronomers can detect faint radio and gamma-ray emissions from Earth as the cosmic rays come into contact with gas and dust as they spiral through space. Scientists are able to determine the structure and strength of Andromeda's magnetic field because of these findings. Comprehending the behavior of cosmic rays inside a galaxy also provides insight into the cosmic circulation of energy, which transfers heat and momentum through the interstellar medium. The procedure is intricate and continuous. Invisible particles interact quietly with the magnetic structure that directs them. Andromeda thus illustrates how even the tiniest influences, invisible but always present in its perpetual movement, may mold the rhythm of a vast galaxy. Unknown high-energy emissions have been observed by gamma-ray telescopes. Astronomers discovered something surprising when they used space-based gamma-ray telescopes to investigate Andromeda. The most intense type of light, gamma radiation, is emitted by the galaxy in a modest but distinctive manner. These emissions originate from areas that appear to have no visible sources rather than from typical stars. Although it is still unproven, one theory is that the radiation could come from the interaction or disintegration of dark matter particles. The acceleration of cosmic rays in Andromeda's magnetic field could also be the source of the brightness. These gamma emissions show that the galaxy is far from tranquil, regardless of the reason massive energy processes are constantly taking place deep within its halo, emitting photons strong enough to travel millions of light years. Every discovery provides a fresh insight into the unseen forces at work in the cosmos, serving as a reminder that even the most serene galaxy may harbor astounding activity. Dark matter interactions may be hinted at by these signals. Although dark matter cannot be seen or touched, it may be visible by the dim light that is created when its particles interact. Some scientists are wondering if they are actually seeing that phenomenon because of the enigmatic gamma-ray glow found in Andromeda's halo. A burst of high-intensity radiation may be released when dark matter particles collide and annihilate one another, according to some ideas. If this is accurate, one of the biggest mysteries of the cosmos may be studied in the Andromeda galaxy, a natural laboratory. Finding such interactions would assist in determining the characteristics of dark matter and offer concrete proof of its existence. The signals are weak and ambiguous, but they have enormous potential. They contend that Andromeda's serene exterior conceals a more complex narrative, one that is written in the invisible physics that controls the structure of the universe itself, rather than in stars or light. Compact stellar remnants and hot gas are visible in X-ray observations. Andromeda shines in more than just visible light. The galaxy appears in a completely different light when viewed in the X-ray spectrum. Numerous intense radiation points, many of which are produced by the remains of dead stars, are dispersed throughout its disk and halo. Black holes, white dwarfs, and neutron stars consume surrounding material and heat it until X-rays are released. There are enormous clouds of hot gas with temperatures of millions of degrees between these compact objects. These bright areas are proof of energetic processes that persist long after supernova explosions. By demonstrating how energy from dying stars affects the development of new ones, the X-ray light sheds light on the galaxy's continuing life cycle. Astronomers are able to see the violence and rebirth that coexist within Andromeda through these observations, as well as the constant change that characterizes the galaxy's history across cosmic time. Black hole binaries are among its brightest X-ray sources. A couple of the bright spots of X-ray light that are dispersed across Andromeda are very noticeable. These are believed to be binary systems made up of a companion star and a black hole, as the black hole's gravity draws matter from the nearest star. The material creates a spinning disk that warms to extraordinary temperatures, producing floods of X-rays before disappearing beyond the event horizon. Such systems are rare and powerful, observable even across the immense gulf of space separating Andromeda from the Milky Way. Observing them helps scientists to examine how black holes evolve and how energy is released from the most extreme conditions known. Each one is a small drama of creation and destruction, a cosmic engine where gravity, motion, and light all meet in a balance so extreme that it pushes the limits of human understanding and the limitations of what light can sustain. Andromeda has experienced multiple spurts of star creation over time. The Andromeda galaxy has not always been stable in its generation of stars. It has seen periods of high activity over billions of years, during which a large number of stars were formed in quick succession. The galaxy's structure was permanently altered by these formation bursts, which filled its spiral arms with dazzling clusters of nascent blue suns. Astronomers believe these times were sparked by gravitational interactions with other galaxies, which compressed clouds of gas and kicked off waves of creation. Andromeda experienced calmer periods in between these outbursts as star formation slowed, enabling the gas to settle and cool. The inherent breathing of a galaxy, a cosmic heartbeat that pulses through time, is reflected in this periodic cycle of activity and rest. The memory of those old explosions glowing as reminders of the galaxy's ever-shifting vibrancy is carried within each generation of stars. Galaxy mergers may have caused these explosions. Galaxies are not isolated entities. Over extended periods of time, they frequently interact, collide, and merge. Such encounters have probably happened numerous times throughout Andromeda's history. Massive waves of star formation are triggered when a smaller galaxy travels through or close to Andromeda due to the gravitational forces that compress its gas and dust. The way the stars are arranged, the disk's distorted structure, and the weak streams that stretch past its apparent boundaries are all reminders of these occurrences. These previous mergers are both records of devastation and instances of rebirth. They helped Andromeda develop into the massive structure we see today by giving it new material and vitality. One of these interactions may be the origin of every star that shines in its spiral arms. Every merging is a silent yet potent act of cosmic creation spanning billions of years. Its halo shows subtle scars from ancient collisions. A huge halo full of the remains of ancient collisions may be seen beyond Andromeda's brilliant disk. The trajectories of smaller galaxies that were ripped apart and swallowed into the larger whole are marked by faint arcs and wisps of stars. Astronomers may follow these spectral trails, which are hard to discern, like fingerprints on the fabric of space, using sophisticated instruments. Each one describes a merger that took place while the cosmos was very young, billions of years ago. Scientists can recreate the timeline of Andromeda's growth by examining their shapes and motions, showing how it has changed as a result of many interactions. The halo is alive with recollection, despite its faintness. A silent testament to the collisions and assimilations that created one of the most magnificent galaxies in the nearby cosmos, each star that floats within it is a part of an ancient echo. A fossil record of those occurrences is provided by the dim streams of stars. Hundreds of thousands of light-years of thin, thread-like star streams around the Andromeda galaxy's main body. These are the remnants of smaller galaxies that Andromeda's gravitational pull eventually tore apart. The orbits they formerly traveled are now traced by shimmering trails formed by their dispersed stars. Stellar streams, as astronomers refer to them, are a type of fossil record that preserves evidence of events that occurred billions of years ago. Scientists can piece together the history of Andromeda's development by examining their position and movements. These star streams show that galaxies develop by eating others, a process of perpetual regeneration that never really stops, much like archaeologists reconstruct history from old ruins. The memory of creation is inscribed in their dim light on the peaceful periphery of a galaxy that is still rebuilding itself from the ashes of the past. Its stellar halo is far larger than we previously thought. Astronomers thought Andromeda's apparent edge indicated the boundaries of its domain for a long time. However, more thorough investigations have revealed that its stellar halo extends well beyond the areas where stars are visible. Faintly dispersed star populations can be found in this halo, which extends almost halfway to our own galaxy. It also contains hot gas clouds, starjets, and globular clusters. The realization of its enormous scope has altered our perception of what constitutes a galaxy's actual size. Andromeda is a massive gravitational structure that occupies a large part of the local group, not simply the bright spiral visible via telescopes. Its halo is a mixture of the old and the new, made up of debris from more recent mergers as well as ancient stars from earlier epochs. It is softly connected to the intergalactic space beyond by a large invisible boundary. Both fresh and old stars can be found in that halo. Astronomers have discovered stars of a wide range of ages within Andromeda's massive halo. Some of them date back to the early stages of galaxy formation, making them among the oldest in the cosmos. Others seem to be far younger, probably taken from smaller galaxies that Andromeda recently joined. With this blend, shows that the halo is dynamic and ever-changing. While older stars gradually drift farther outward, new stars are added through continuous interactions. As a result, the halo is both a construction site and a museum, welcoming the results of more recent cosmic events while conserving artifacts from the distant past. Scientists discover how galaxies put together their mass and structure by examining this intricate environment. Each star in the halo contributes a strand to the ongoing narrative of Andromeda's development. Over the unending night of cosmic space, a story is continuously being told. Intergalactic space and the outer halo blend together almost perfectly. The outer halo of Andromeda steadily thins away from its luminous center until it blends in with the immensity that exists between galaxies. There isn't a distinct line separating one from the other. Rather, the dim background of intergalactic space blends with the gas and stars as they recede into the darkness. This boundaryless transition demonstrates that galaxies are overlapping structures within a continuous cosmic web rather than isolated islands. The soft pull of the cosmos as a whole replaces Andromeda's gravitational pull in the outer halo. Stray stars and drifting clusters roam freely in that area, no longer confined to a distinct center. Astronomers get a unique look at the relationship between galaxies and their surrounding environment by studying this outer region. It is the silent edge of a system that softens into infinity, yet never really ends. Some of its stars are billions of years older than our Sun. A large number of the stars in Andromeda's halo were formed long before the Sun. Some may have originated during the early stages of the universe, making them older than 10 billion years, while entire civilizations have come and gone on far-off worlds. These old suns have burned steadily for ages, their light unaltered. Astronomers can learn about the conditions that existed close to the beginning of time by studying them. They arose before the universe was enriched by generations of supernovae, as seen by their composition, which shows that they contain extremely few heavy elements. A record of the earliest chemical and physical processes that shaped all subsequent stars can be found in their dim glimmer. These ancient lights still shine softly throughout Andromeda's enormous territory, connecting the galaxy's current splendor to the universe's profound beginnings. In brilliant nebulae, others are just starting their lives. Creation persists even in a galaxy full of old stars. Right now, new suns are being formed in the hazy gas clouds, and spiral arms of Andromeda gravity pulls cold hydrogen into dense knots inside bright nebulae, where they collapse and catch fire. Nearby gas shimmers in pink and crimson as a result of these newborn stars' dazzling energy illuminating their surroundings. While some are enormous and transient, others resemble our sun and could endure for billions of years. The narrative of continuity is conveyed by the contrast between the young stars and their older neighbors. Since the galaxy's formation, this cycle has never ended. Every new star contains recycled materials from innumerable previous generations, demonstrating that creation is still in progress, eternal and continuous within the silent graph. Even in a universe that is billions of years old, the starlit clouds of Andromeda glow. Its chemical makeup reveals a tale of progressive enrichment. The components of Andromeda's stars provide insight into the galaxy's past development. The most basic elements of the early universe, hydrogen and helium, make up the majority of the oldest stars. However, evidence of heavier components like carbon, oxygen, iron, and gold can be seen in younger stars. These were produced inside earlier star generations and dispersed throughout the galaxy when those stars exploded as supernovae. This cycle of birth and destruction enriched Andromeda's gas clouds throughout time, increasing the complexity of the composition of each new generation of stars. Astronomers can reconstruct this lengthy chemical development, showing how the galaxy changed from a primordial swirl of basic gases into a rich environment capable of creating planets and possibly life by examining the light from these stars. Andromeda's chemistry thus acts as a chronology and a symbol of the universe's perpetual replenishment of substance. Heavy elements have been injected into the next generation of stars. A large star's enriched components are dispersed into space when it explodes as a supernova at the conclusion of its life. The ejected gas and dust eventually combine with the surrounding material to form new clouds, which give rise to new stars. The overall composition of the galaxy is gradually changing as each new generation carries more heavy elements than the previous one. This process has been taking place in Andromeda for billions of years, transforming basic hydrogen into an intricate mixture of cosmic components. Such star furnaces produce the carbon in our bodies, the iron in our blood, and the oxygen we breathe. Thus, Andromeda's shimmering light provides proof of an ongoing cycle of creation as well as the shine of far-off suns. In the never-ending rhythm of its stars, the galaxy is a great alchemist, transforming the simple into the complex and creating the fundamental elements of life. These elements may be found in many of its planetary systems. The planets that surround the stars in Andromeda acquired the same elements as the stars themselves, which were formed from gas that had been enriched by innumerable generations of ancestors. Earth-like carbon-based molecules, metallic cores, and rocky surfaces are probably present on worlds circling these stars. Some might have methane, carbon dioxide, or water vapor-filled oceans or atmospheres. Others may have volcanic moons or icy rings. The existence of these elements implies that the galaxy may contain many of the conditions required for complex chemistry and perhaps even life. The light from these far-off worlds' parent stars has the signatures of the materials that form them, even if we are unable to see them yet. Andromeda is similar to our own Milky Way, a galaxy with billions of stars and the raw materials of life. Across the vast expanse of space, every system is a silent possibility just waiting to be found. The brightness of the galaxy changes slightly over time. Although Andromeda seems steady and continuous to the unaided eye, accurate measurements reveal that its brightness varies somewhat over extended periods of time. These fluctuations are caused by supernovae, fluctuating stars, and changing patterns of gas and dust that impact how their light reaches us. While some areas become dimmer as huge stars burn away, others become brighter as new clusters of young stars develop. Tiny variations in its apparent light can also result from the motion of cosmic dust. The slight alterations show that a galaxy is a living system rather than a static entity. Breathing gently through cycles of growth and deterioration, astronomers can monitor Andromeda's continuous evolution by tracking these minute changes over time. Its constant yet ever-evolving light is a cosmic heartbeat that has been seen throughout history, a soothing reminder that motion permeates even the farthest objects. The sluggish heartbeat of star formation cycles is revealed by this variation. On a scale far larger than our own, the Andromeda galaxy is alive and well. Light rises and fades in a rhythm that develops over millions of years over its massive spiral disk. Slow, recurring changes that reflect the speed of creation itself have been discovered by astronomers examining its brightness. After collapsing to create clusters of young stars, gas waves become quiet as the material is consumed or carried away by stellar winds. The galaxy follows a constant pulse that can only be determined by meticulous study over the ages, brightening, dimming, and then brightening again. The galaxy seems to have its own heartbeat, one that beats in ages rather than seconds. Seeing these small shifts is like feeling the breath of the cosmos inhaling and expelling light. The universe creates and rests in an equilibrium as ageless as gravity. Even the galaxy's rotation can be detected by astronomers. The grace with which Andromeda rotates in space is too slow for the human eye to see. By examining the hues of its light, astronomers were able to determine its spin. The brightness on one side of the galaxy changes to a pale blue as it wanders slightly toward us. The light on the other side grows somewhat red as it moves away. The entire galaxy is rotating as these changes demonstrate. There is a tremendously huge black hole at its center, which is surrounded by billions of stars. Every visible point of light is a component of that enormous movement. A piece of a huge celestial wheel spinning slowly and precisely. A single revolution takes hundreds of millions of years to finish. However, the pattern never breaks. Scientists can weigh the galaxy by tracking its rotation, revealing the dark matter that envelops it and holds its stars together in an invisible gravitational halo. A single spin takes hundreds of millions of years to complete. The Andromeda galaxy rotates so much that it takes hundreds of millions of years for it to complete a full revolution. During that period, entire species may emerge and disappear on planets circling far-off stars as the galaxy continues to move patiently. Each cluster, cloud, and star has its own orbit. However, when combined, they form the magnificent spiral that is visible from a distance. Over unfathomably long periods of time, gravity maintains harmony by drawing inward while motion pulls away. Even the huge Milky Way would appear to float beside such a cosmic stream like a leaf. Imagining Andromeda's gradual rotation is a window into the universe's deeper rhythm, where time seems to go on forever. The record of billions of suns who have lived, shone, and died back into starred dust is carried by the galaxy's ancient rotation, which moves with assurance rather than speed. Over very long time scales, the spiral pattern is extraordinarily stable. Though its stars are constantly moving, the Andromeda galaxy's spiral arms have held their graceful form for billions of years. These arms are not permanent lines of stars, but waves of density that move through the disk like ripples across water. Where the waves pass, gas is squeezed and new stars ignite in bright clusters. As they go forward, those areas disappear and are replaced by new ones. Yet the pattern remains the same. This delicate structure is maintained over time by gravity, motion, and interstellar gas flow. The galaxy's shape does not change despite its evolution, a stable harmony amidst a universe marked by change. Seeing Andromeda spirals is like seeing motion give way to order, a balance so exquisite that it seems alive. The arms are echoes of eternal forces that have shaped the framework of creation itself. Not just characteristics of light, Andromeda contains a sister galaxy called Messier 32. Nestled just below Andromeda's brilliant disk sits a tiny galaxy known as Messier 32. In contrast to its large neighbor's sweeping arms, it appears as a smooth oval light that is dense and compact. It is noteworthy on its own, even though it only has a small portion of Andromeda's stars, a tightly packed sphere of old suns. According to astronomers, Messier 32's outer layers were once removed by Andromeda's gravity during previous visits. Both galaxies may have been influenced by these intimate encounters, which warped Andromeda's disk and changed its internal motion. The gravity of the larger spiral continues to impact Messier 32, which now orbits as a faithful companion. It serves as a subdued reminder that even tiny galaxies are crucial to the narratives of larger ones. We may discern the faint signs of cosmic camaraderie inscribed in light and gravity in its gentle radiance. Messier 110, a smaller neighbor, also circles it. Messier 110, another elliptical galaxy that moves slowly via its gravitational field, wanders farther away from Andromeda's brilliant core. Even if this companion is bigger than Messier 32, it is still much smaller than Andromeda. The attraction of its giant companion has long since robbed it of its gas, leaving it glowing dimly with the red light of old stars. It will probably eventually blend in with Andromeda's expanding halo. Its stars were devoured by the larger whole. These companions participate in the gradual dance of galactic evolution rather than being merely satellites. Every orbit modifies them, quietly and imperceptibly reshaping their histories and forms. In order to comprehend how galaxies interact and develop through merging and exchange, astronomers study them like a wandering ember next to a roaring fire. Messier 110 travels through space, little but bright, bound to merge with the bigger light one day. These friends might become part of its bigger body. Due to Andromeda's strong gravitational pull, the tiny galaxies that surround it are gradually spiraling inward. Their orbits will deteriorate over innumerable eras until they are engulfed by the greater spiral. Faint star trails that wind across Andromeda's halo like pale rivers of light are the result of numerous previous mergers of this kind. The expanding galaxy gains fresh mass, stars, and narratives with each merger. The impacts are significant, although the process is slow and mild, occurring over billions of years. Galaxies change and rejuvenate as a result of these silent collisions. What starts out as division turns into unity. Once in orbit, it becomes a part of the whole. Andromeda's friends are already traveling this route. Their futures are already in motion. They serve as a reminder that, in the universe, endings are frequently beginnings in the form of light. Their shapes are already warped by gravitational tides. Andromeda's gravitational pull is still evident in the smaller galaxies that orbit it. Their once round shapes seem stretched, as though pulled in the direction of their enormous companion. They are followed by streams of stars that are ghostly and faint, unseen to the human eye, but observable through sensitive telescopes. Tidal forces operating over light years are responsible for the gradual disintegration of entire galaxies, as evidenced by these tiny threads. The stars from these streams will eventually merge into Andromeda's halo, making it impossible to tell them apart. The structure of Andromeda's dark matter halo, which stretches much beyond what is visible, is studied by astronomers using these distortions. Every warped form is an indication that invisible gravity is at work. These subtle remnants show transformation rather than destruction. Under the uninterrupted supervision of its own inherent order, the universe is quietly and magnificently reshaping itself. Andromeda is a member of the local galaxy group. Andromeda is a member of the local group, a galactic family. Rather than being solitary in space, more than 50 galaxies make up this cluster, ranging from large spirals like the Milky Way and Andromeda to tiny dim dwarfs dispersed over the surrounding area. Gravity holds them together as they drift through the dark together, circling a common center of mass. Millions of light years make up the local group. However, its members continue to be interconnected, navigating a complicated web of relationships that influence their fates. Galaxies combine, trade materials, and affect each other's trajectories within it. Being the biggest, Andromeda has a strong influence that extends well beyond its apparent boundaries. Our native region of the cosmos is the local group. The stories of galaxies are woven together like stars into a single, enormous constellation in this peaceful neighborhood within the huge cosmic edifice, the Milky Way, and several dwarfs are also part of that group. Numerous smaller galaxies circle the twin giants of the local group, the Milky Way and Andromeda. Some are spherical groupings of old suns, while others are asymmetrical clouds of gas and stars. Gravity binds these dwarfs to their larger friends, causing them to travel through space in complex patterns. Their orbits can span billions of years, and occasionally they get so near that their stars are ripped apart and added to the halos of larger systems. Despite their modest size, they are crucial to the evolution of galaxies because they serve as the foundation for larger ones. Together, the Milky Way and Andromeda control dozens of these companions, creating a little cosmic ecosystem. The universe is governed by a careful balance of motion and attraction, which may be seen by observing them. A harmony that can accommodate even the tiniest star systems within its subdued layout. They all revolve around the same gravitational center. The local group's galaxies don't wander aimlessly through the emptiness. They revolve around a common gravitational center, which is determined by the total mass of all of its constituents. Neither Andromeda nor the Milky Way is located exactly there. However, each takes a wide and deliberate route around it. They are all connected by an invisible gravitational pattern as their lesser partners follow. The profound harmony that unites galaxies throughout space is revealed by their common motion. The cosmic law that links stars to galaxies and planets to stars is the same fundamental attraction that drives all orbits, regardless of their length. This system can be visualized as a slow heavenly dance. While each galaxy follows its own path, they all revolve around a center that is nothing more than symmetry, balance, and the silent force of gravity. The small group itself moves in the direction of an even bigger cluster. Not even the local group is motionless. It travels slowly across the cosmos, attracted to the Virgo cluster, a larger cluster of galaxies. This motion is a part of the enormous flow of matter throughout the universe, yet it is undetectable to the senses, but can be recorded by sensors. Over unfathomable scales, everything wanders toward something else under the influence of gravity. It will take billions of years for the local group to travel over the vast cosmic web that connects galaxies into ever larger structures in order to reach Virgo. Despite the enormous distances, the forces at play are subtle and enduring, quietly determining how the cosmos is shaped. This movement encompasses our entire galactic neighborhood, moving like a leaf on an imperceptible stream. We learn from Andromeda that nothing in the universe exists in isolation. Every cluster, galaxy, and star travels in an infinite way in connection to the total. The Virgo supercluster, which contains hundreds of galaxies, is located beyond that. The Virgo supercluster, a huge and complex structure made up of hundreds of galaxies, extends well beyond the local group. It is one of the major filaments of the cosmic web, extending over 100 million light-years. Clusters and groups, including our own, come together within it to form enormous patterns that stretch as far as observation permits. Near its center is the Virgo cluster, which is illuminated by the combined light of many suns. Gravity pulls a local group slowly inside as it wanders on its edge. This supercluster is a part of a larger network that connects all matter in the universe, not a solitary island. Every atom, cluster, and galaxy takes part in this enormous scheme. Thinking about the Virgo supercluster means confronting the vastness of life itself, where even galaxies seem like tiny dots in the infinite depths of cosmic space nearby. Its brightest members are Andromeda and the Milky Way. Two galaxies stand out above the rest in the local group, Andromeda and the Milky Way. Each glows with the gentle collective light of creation and is home to hundreds of billions of stars. The Milky Way would look much like Andromeda does to us from Andromeda's point of view, a huge spiral of starlight with dim partners. Mutual gravity holds the two galaxies together as they gradually approach one another across the emptiness. Our area of the cosmos is illuminated by their combined brilliance, acting as beacons for far-off onlookers who might be looking in our direction. They serve as the local group's twin anchors, defining its structure and balancing its movements. When combined, they represent inevitability and symmetry. Because of their strategy, they will eventually become one. The universe demonstrates how action and beauty are entwined in their brightness, shining together throughout the centuries. We can better comprehend the evolution of galaxies by studying Andromeda. Astronomers can trace the entire history of a galaxy by studying Andromeda in incredible detail. Since it is so close, its stars provide information about its formation, evolution, and the growth and evolution of galaxies throughout the cosmos. Scientists can relate its history to that of the Milky Way by looking at its spiral structure, halo, and star-forming areas. Every finding in Andromeda illustrates how galaxies recycle their material through successive generations of stars, reflecting something about ourselves. It offers a window into the past and the future, a real-life illustration of cosmic evolution taking place in front of us. We detect universal patterns in its light, from the largest cluster to the tiniest dwarf galaxy. It takes more than just observation to study Andromeda. It is taking part in a collective narrative written in the star language. It provides a window into the far future of our own galaxy. In addition to being a neighbor, the Andromeda galaxy serves as a mirror reflecting the Milky Way's future. Gravity will drag the two galaxies together over the course of the next 4 billion years, causing a gradual and elegant merger. When that moment arrives, the galaxies will merge and reconfigure, causing the night sky of any surviving planet to flare with brightness. The great distances between stars prevent them from colliding, yet their orbits will change to create new, beautiful structures. One huge, elliptical galaxy that is brighter than either of its ancestors will be the end result. This is not a story of destruction, but of metamorphosis, where two great spirals join to create something altogether new. In Andromeda's light, we see our own fate scrawled across the heavens, a promise of change that is both gentle and eternal. Every telescope generation unveils fresh secrets in its radiance. From the first refracting lenses to the most modern space observatories, each generation of telescopes has brought Andromeda into greater focus. What originally appeared as a thin cloud of light now exposes intricate lanes of dust, swells of gas, and groupings of stars numbering in the thousands. Observations at multiple wavelengths, including radio, infrared, ultraviolet, and X-ray, unveil still more layers of structure and energy. Every advancement broadens our astonishment and deepens our comprehension. The more accurately we see, the more mystery we discover, as though the galaxy were revealing itself with each look. Andromeda serves as a reminder that exploration is an unending adventure, and that knowledge and curiosity are limitless companions. Our relationship with this nearby galaxy, which never stops sharing its light and mysteries with anybody who is prepared to gaze into the silence of the night sky, is growing along with technology. From their backyards, even amateur astronomers can take pictures of it. The Andromeda galaxy is brilliant enough to be seen in a dark sky without a telescope. Despite its great distance, it appears as an extended glow through binoculars or a tiny camera, with its central bulge gently illuminating the surrounding darkness. Using basic equipment, amateur astronomers all around the world take pictures of it, layering lengthy exposures to expose its delicate spiral arms. Light that has traveled over 2 million years to reach Earth is captured in each shot. Sky watchers are immediately connected to the larger universe through this experience, which serves as a reminder that the universe is not inaccessible, but rather subtly exists above all of us. Because of its accessibility, Andromeda represents wonder that is within grasp and serves as a link between curiosity and infinity. The cosmos becomes a companion in the silence for those who gaze up, even from a peaceful backyard, telling tales written in light. We are linked to a big cosmic narrative by its subtle shimmer. You can witness photons that started their journey before humans ever existed when you gaze up at the dim light of the Andromeda galaxy. For almost 2 million years, that ancient light has traversed the silent emptiness, bringing with it the history of innumerable suns. The memory of creation itself, star births and deaths, galaxy collisions, and time's gradual breathing are all contained within that shimmer. Seeing it serves as a reminder that light connects everything in the universe, recycled from the same universal source. The identical atoms that shine in Andromeda's stars also circulate through our bodies. It reflects our beginnings and our fate with a brightness that is both familiar and far away. Every time its light reaches Earth, it serves as a reminder that we are a part of a narrative that is far older and more timeless than life itself. We get a glimpse of the universe's infinite development through Andromeda. Astronomers use the Andromeda galaxy as a destination, but it also represents the universe's ongoing transformation. In its spiral arms, whole systems rise and fall in an unending cycle, with new stars igniting as others fade away. It's like seeing the universe breathe. The imprint of that developing narrative is carried by every photon that makes it to us. We can observe that the universe is never at rest in Andromeda. It perpetually generates, changes, and renews itself. Its light has journeyed through time to inform us that everything is related by gravity and the flow of energy, and that existence itself is motion. Looking at Andromeda is like watching creation unfold, a continuous narrative spanning billions of years. It serves as a reminder and a promise that we are a part of the universe's silent expansion, and that it is continually evolving. Allow yourself to float into the peaceful silence of space as the Andromeda galaxy's brilliance fades from our minds. Imagine floating outside of the Milky Way and beyond the reach of any star, where the only light in the dark is the gentle glow of galaxies. Everything moves in a steady, harmonious rhythm there. Even though the stars are silent, their light softly hums in your head, a gentle reminder that peace exists even in vastness. The cosmos doesn't move quickly. It grows and shifts, but it always does so patiently. The galaxies gracefully rotate. Calm gas clouds are the birthplace of stars, like a slow tide on an endless shore. Time itself unfolds.